Hello guys, so today we're going to talk about inline functions in Kotlin. So Kotlin compiler provides us a way using which we can inline, means copy the body at the calling place. Which is known as inline functions. So this helps us in improving the performance in certain scenarios. So let's look at some code and understand like what inline functions are, how Kotlin compiler compiles them, and what does it look like after they're compiled, and what are their benefits, and in what scenarios should we not use inline functions. So let's start with the code first. Let's try to understand this code. It's very simple, right? All it's trying to do is it creates a list of numbers from 1 to 200, right? We use a range function, and then it iterates over it. So by iterating, it uses a for each, and then we pass a lambda. This is the lambda that we pass, and we call double the number, right? So this double the number is a contrived example, but sometimes we have some mathematical functions which are very simple, but still we extract out the common logic, right? Like maybe we are multiplying with some constant, so or we are doing like some calculations. In those cases, we still want to extract out that logic into a central place, right? So there is like a slight overhead, which is we for every for each iteration we are calling a function, right? So maybe it would be better if we just do it like this, right? Like performance wise, like it could be better if we just do it into two, right? This is a bit more performant as compared to calling the function. So uh, Kotlin, and also let's look at the generated bytecode, like Java bytecode for this. And let's try to compare, like see when this gets compiled to Java code, how it looks like. So here list of numbers, and then we say for each. This is converted to a while loop, right? And in the while loop, we are again calling the function, passing it like this function, which is like this variable, which is it, right? And then here is the function which gets declared like double the number, which returns I to 2, right? This is how like the Java code would look like. So let's try to use inline function in this scenario. So now we would say inline function. So we have inline. Now, so all we did is just add an inline here, right? So let's look at the Java code corresponding to this inline function. So if we see the Java code here, so this is the iteration that we do, selection long, right? And here this is the iterator. So what we're trying to do is we create a variable here, right, which is we are multiplying it into 2, right? And this is the variable. So basically, this is the variable that's being used, right? So if we add like one more line of code here, like maybe we multiply and print, right? So we say println, and let's remove this, clean this up, and let's again decompile this code to Java. So here if you see again, like the function, right, the body, the contents of the function, which was double the number, they get pasted or inlined where the caller was calling the function, right? So here we were doing for each, and the for each is equivalent to a while loop. And here only, like if you see, we multiply by 2, and then we print the contents, right? So variable date is printed, which is exactly what we do here. So inline functions, they help us in like copying the code and just placing it the caller. So we get some performance benefits. And in this scenario, if you see like Kotlin compiler would just print a warning for us, right? Expected performance expect from inlining is insignificant, right? Because there is not too much which we get, right, out of doing this. So we have to maintain a balance. Like in some certain scenarios it is useful, in certain scenarios it does not improve the performance a lot. So, and like suppose the function is of 20 lines, right? In those scenarios, like if we're using it like a lot of places, all those 20 lines will be pasted at each location, right? So for it is very difficult to for the Kotlin compiler to know like whether it is like just having one line or multiple lines. That's why it prints something generic, right? But suppose it was like a big function, then that is copied everywhere, right? And the bytecode expands a lot. So in those cases, instead of getting a better performance, you might like that might further impact the code, right, in a bad way. So uh, it is like we have to think before using inline functions when we are using them in the simple scenarios. There are certain scenarios in which it makes a lot of sense to use inline functions. So let's do that. So suppose let's see those scenarios. So I'll just update the code and we'll run into that scenario. So let's look at our second example. What we're doing here is we create, like again, we have a list of 200 functions, but in this function, we pass the number, we double it, and then we pass that what do we want to do with that function, right? What do we want to do with it? So this is like a lambda which we pass to that function. So the lambda, what it does a print of first like it's log statement which prints the time and then prints a start, and then like the number itself, right? The double number, and then it prints a now and then like again a log statement. So let's see. Now I have removed the inline, right? So we just have a normal function. Let's see how its Java equivalent code looks like. So if you look at this, the Java equivalent of this, so it says double and do something, right? Like so for loop, this is for each is converted to a while loop, right? And it is this it, right? Which is the actual number which we iterate over and get the int value. And then do something, it calls to do something, and it passes the number which is it, and it also passes new instance of this class, right? This class corresponds to this lambda, right? So let's look at this class. So basically the contents of the lambda are pasted into an invoke function, and like if you see here now, right, we use now and then we use a start, and this now is stored as a field, right? So which we use here, and then we have these log statements start and end, and here we are printing the double variable, right? So suppose like in this case we're doing 200 iterations. So for each of those iterations we will have a new instance of this class, and then we're going to pass this instance and a function will be invoked on it, right? So looking at this code, we would never imagine that there is a class that would be created and new instance would be created for each iteration. Suppose we're doing a million iterations, like it would prove to be expensive because a million instances could be created. So now if we inline this, let's see how the code would look like. So we have inline, let's see the Java equivalent of this. So the Java equivalent of this now, after inlining, right, the contents have been pasted within the while loop itself, right? So there is no new variable, there is no lambda, like there is no class and all that's there for this lambda, right? The contents are straight away pasted within the while loop. So you can see in this scenario, like inline makes a lot of sense, right? And it would really be like a like a good performance benefit. So like whenever you see we are passing lambdas and all to a function, and those are pure functions which are not dependent upon any external fields and all. In those cases, it does make sense to declare them and as inline because we can just prevent those extra uh, like those extra uh, instances and all of the lambdas to be created. So I hope this is useful and would help you in deciding when to use inline functions and when not to. And if you have any questions, let me know in the comments below and I'll reply to them. Thank you.